Thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello everyone, and thanks for tuning in to week 20 of the Concentrator Talk, brought to you by the Oxygen Alliance. My name is Mwawi Lungu, and I'm very pleased to be hosting the call today. Joining me on the call are my colleagues Amaprit Rai and Timothy Mtonga, along with our usual technicians from OpenO2 and Sunrise. On the technicians panel today, we have Paulina Mohosho joining us from Johannesburg, South Africa. We also have Kowinda Singh, who is joining us from Chandigarh, India. And we have Mteto Sinjani, Chimwemwe TSC, Efa Solomoni, Linda Mishoni joining us from Lilongwe, Malawi. So as we all know, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time. So here we discuss the different aspects of oxygen concentrator assessment, use, and maintenance. So today, as we usually do, we'll be having a topic of interest, and we will be discussing about sieve bed refilling versus sieve bed replacement. So be on the lookout for that. All right, so now moving on, before we jump on to our normal schedule of our questions, I would like to just ask the audience if anyone has an update that they would like to give on what they have been working on or what they are working on, and we will then after jump on to our questions. So I'll leave the floor open, and then you can just come off mute and give us your update.
Okay, so this week we are working at Moa Mission Hospital where we are fixing different models of concentrators. So we found about 1640 concentrators. So that's after assessing the wards, and the problems were mainly the compressors and the beds. So we were able to service them and refill the beds. And so far, we're about finishing our job this side, and we have managed to fix all the 16 concentrators. Thank you.
Thank you very much, Sharon. What models have you been working on that site, if I may ask?
Okay, so we have come across the ASAP, that's the New Life 10, and the Interceptor, the 5 liters, the Devil Breeze 525, the Drive. We have made Olive 10, yeah, and the Respironics Millennium M5.
Okay, great. Have you had any issues? I hear you mentioned the Olive 10.
Okay, so for the Olive 10, first of all, we assessed it in the wards, so it was performing quite okay. But after some days, they complained that it was raising an alarm and it was getting hot, like the temperature was getting a little bit high. So we asked them to bring it to us so that we can assess them. So we have managed to leave them for a test, like we switched them on in the morning. Till now, they're still running. We're not getting any alarm. So when we're assessing in the wards, we try to advise them that whenever they're operating on they have switched on the concentrator, they have to make sure that they don't leave it close to the wall. At least they need to give it some space. So I think that's really a main problem this side, because we have had like 2 concentrators, the same model, they are behaving the same way. So it's a little problem, but we have managed to discuss it with them because everything looks fine. We have tried to open it up. Everything is just functioning properly. But to them, if it's in the ward, it performs that way. But if as far as we have assessed them, they're just performing fine.
Okay, thank you very much, Sharon, for that update. If anyone else has an update, I'll just ask you to paste it into the chat, and then we can all read it from there. All right, so now we'll jump on to our questions that we have received for this week. So our first question says, I have been hired by a private company to install and test newly purchased Cantor V8 oxygen concentrators in several district hospitals in the Eastern Province. While testing for pressure in 3 different concentrators of the same model using a pressure gauge embedded inside an oxygen analyzer, I noticed that the float inside the flow meter was not going down to 0 in the said 3 concentrators. I tried leakage tests on the pipes but did not detect any leaks. Is this a common problem with these concentrators, or is there something I am missing? So I will ask Chimwemwe to answer this one.
Thank you, Maui. So, under normal working conditions, the flow meter float in the Cantor VAWNNS model goes down to 0 liters per minute when a pressure measuring device is connected to the patient outlet. So with your question, the very first thing to do is to check if the problem itself is not originating from the pressure measuring device. As any leak present in the measuring device can lead to the flow meter ball or float not going down to 0 liters per minute. So to check if the pressure measuring device is the cause of the problem, you can use your thumb to gas patient outlet and see if the float ball is going down to 0 liters. Another way is to connect the pressure measuring device to another working oxygen concentrator and see if the problem still exists. Coming to another likely cause of the flow meter float not going down to 0, the other likely hidden source of a leak in Cantor VAWNNS is the oxygen sensor itself. From what we think could be the manufacturer's problem, most sensors on the Cantor VAWNNS have visible cracks on them. So to check if it's the sensor that's causing the problem, try to bypass the sensor by connecting the tube coming from the flow meter directly to the patient outlet and do the pressure test again. If you see that the flow meter ball goes down to 0 liters per minute, it's time to change the flow meter sensor, the oxygen sensor. So you can see in the graphics, that's the oxygen sensor found in the Cantor VAWNNS model. Thank you.
Thank you very much, Chimwemwe, for that explanation. I hope that was clear enough for everyone. But in case we have some questions or comments on the explanation that he has just given us, we are welcome to add on to the explanation. All right, it seems we do not have any questions. So moving on to our next question. So it says, I am a biomedical technician at Nsanje District Hospital, and I have been working on a Respironics Everflow concentrator. When I switch on the concentrator, the compressor makes a sound like there is a blockage in the air passages. When that happens, the concentrator vibrates, but the relief valve doesn't open. Is it possible that one of the valves is faulty? If not, what can be the problem and how can I solve this one? So I will ask Mteto to take this one up.
Yeah, sure. Thanks, Maui. So Respironics Everflow concentrators use pilot valves, which are a little different from the valves we usually come across. And these switch between 2 sieve beds when the pressure reaches a certain value. So in this scenario, there are a number of things that might be wrong. So firstly, you have to measure the compressor output pressure. In order to do that, you need to disconnect the hose pipe from the compressor going to the sieve beds, and then connect a pressure gauge to the pipe, and then switch on the concentrator. So from this setup, you should be able to know how much pressure the compressor is producing, and you also notice, you also actually get some positive feedback of the relief valve if it's working. So if the relief keeps popping, you can actually block it so that you get the maximum pressure, the compressor can produce. So compare the pressure you get at that moment on the gauge with the manufacturer's performance chart of that model of compressor. So in this scenario, most of the Respironics have like the 2450 compressor. So if the pressure you're getting is below than the recommended, you will need to actually service the compressor. On this one, you actually have to have the right caps and the sleeves for this model. When you're done with servicing, you can actually check the performance again. Secondly, if air is passing through one seatbed freely and it sounds blocked when it's passing on the other seatbed, it's possible that one of the valves is actually faulty, or one of the beds is blocking the air. So if you have lamps inside the seatbed, it might actually be blocking the air. Else, if the compressor is blocked, either way, this might indicate that the seatbed are not in a good condition, and you might actually need to refill with a new zeolite. So remembering that if the pressure in the seatbed does not reach what the valves need to switch, then the valve will not switch. So if the zeolite in the seatbed is also blocking the air, then the valves will not function as well. So we can see in the graphics there, those are the pilot valves from the Respironics Everflow. So thirdly, the pilot valves are supplied with 12 volts from the control board. You need to check if the voltage supplied is adequate. So you can do this by using a multimeter. So just follow where the black and red wire connects to the control board, and then you put your multimeter in DC voltage mode, and then you can see if you're getting like 12 volts on the control board. The next step you do is you need to refill your seatbed. So make sure that you disconnect all the pipes and the cable ties connecting to the bed. So the product tank of the Everflow actually looks like a seatbed, but then it has a regulator, a pressure regulator connected to it. So you need to be careful when handling it. It can easily break if it's not handled carefully. So you need to remove the regulator, and in order to do that, you rotate it in a direction where it can move freely, and then you pull it out. So when the regulator is removed, you can now actually open the seatbed. You need to actually be mindful the type of zeolite you put in the Respironics seatbed. So for our various tests, we discovered that the sodium-based zeolite does not perform well in this type of concentrator, but then the lithium-based one is the best choice for this model. So when you have refilled your seatbeds, you can now press back the regulator and then make sure it's locked, because high pressure can actually pop it out. So after that, you put back the beds in the concentrator, and then you test for leakages using some soapy water while the concentrator is on before you close it. The last thing to check is if the valves are switching. Make sure the compressor is placed correctly and the fan is working perfectly. If the valves are not switching on, and you are sure that you're getting the 12 volts I just mentioned from the control board, I would advise to replace the valves. Else, if everything is working as perfectly, switch off the concentrator and then close it with the screws. Test the concentrator for 2 hours just to monitor the performance before you push it back to the hospital wards. Thank you, Maui.
Thank you very much, Mtedo, for that explanation. I hope that was comprehensive for everyone. So we have a poll at the end of this question. So Amapri, if you would please launch the poll.
I will do. And while I do that, Maui, if you will explain to everyone how to access the poll.
Yes. So if you are tuning in using your mobile phone, just go to the bottom right of your screen and you see a menus option there. You click on the menus option, a window will pop up where you have a number of buttons, and activities button is one of the buttons that is listed. So you click on the activities button, it will open up a window where pause is one of the options listed. If you are tuning in using your computer, then go to the bottom right of your screen. The icon on the far right is the activities button. So you click on that one, it will open up a window where you find the pause menu listed.
Thank you, Maui. So our question was, do you understand how a pilot project works? And the votes have come back in, and it is 50-50. So this may be something that we want to spend some more time doing a educational session on. Now that you've explained how to get to the polls, we are seeing a lot more of yeses than nos, but still perhaps a good topic to dive more deeply on in the future. Thank you.
Thank you very much, Amapreet. Yeah, I think we need to put that in line as one of our topic of interest. So moving on with our questions, our next question says, I am a biomedical technician and I have just repaired 2 air-safe elite concentrators, which are working perfectly, but they do not have gross particle filters. And at the moment, we do not have spare gross particle filters. What would you recommend me to use in place of the gross particle filter as we wait for the filters to be purchased? Or can these concentrators be taken to the ward without the gross particle filter? So Paulina, if you would please answer this one.
Thank you, Mabi. Gross particle filters, which are also known as cabinet filters, prevent large dust particles from entering into the concentrator. Small dust particles that make their way through the gross particle filters are trapped by the intake filter, thereby ensuring that you have the required oxygen purity level. The original gross particle filters that come with oxygen concentrators are loose, such that they do not restrict the entry of air into the concentrator. Therefore, I would recommend you to use something which is not very compact. For example, you can use a gauze bandage as a gross particle filter while waiting for the filters to be purchased. Using a compacted material such as a sofa foam as a cabinet filter will restrict the airflow more, which will affect the purity of the concentrator. As mentioned above, the gross particle filter prevents large dust particles from entering the unit. So running the oxygen concentrator without the gross particle filter results in particulates entering into the concentrator, which in turn may cause blockage in the valve block, and also the dust may contaminate the zeolite, thus reducing the oxygen purity. So to keep the oxygen concentrator running properly and producing the required oxygen purity level, the gross particle filter needs to be cleaned with water on a regular basis. And if there is a need to keep the concentrator running while the filter is being cleaned, a spare filter, if available, can be used. It is recommended that the gross particle filter must be cleaned weekly using soapy water and should be left to dry before being put back on the concentrator. Thank you, Mabi.
Thank you very much, Paulina, for that explanation. So we have another poll at the end of this question. So Amapreet, if you would please launch that one up.
Yes, we actually have 2 polls. So I will launch the first one right now. And that is, have you ever used gauze as a gross particle filter before? And we'll give everyone a few seconds to answer that one. And it looks like it is pretty split, more no's than yeses, but still some yeses. So hopefully, if you do find yourself in a situation without gross particle filters, now you have something that can be used in place. And our second poll is, how often do you clean the gross particle filter? So this is a very interesting question because I think there's always guidelines on it, and the field doesn't quite operate like that. But our options are weekly, monthly, or quarterly. And if there's someone that wants to talk about this and how often they clean those filters, of course, we have a few minutes right now to talk about that. I think so far we're getting most votes on weekly. All right, Molly, back over to you. No one else voted for anything else, only weekly, which is great.
Great, thank you very much, Amapreet. So I guess they all attended the topic of interest where we were discussing about the weekly checklist. All right, so moving on with our questions. Our next question says, with continuous use, the inside of an oxygen concentrator accumulates dust. This dust can also accumulate inside the compressor. I am aware that an oxygen concentrator uses an oil-free air compressor. What is the best way to clean a dusty air compressor? Is it okay to use an alcohol-based solution for cleaning? So Chimwemwe, if you would please answer this one.
Thanks again, Maui. So the air compressor is one of the main parts of an oxygen concentrator. It pulls in ambient air and increases its pressure as part of the pressure swing adsorption process. The ambient air that is pulled in can have dust particles which can accumulate within the walls of the intake hose pipe and sometimes within the inside of the compressor. The closed particle filter and the intake filter are used to prevent the particles and dust from accumulating inside the airways and affecting the purity of the air. Firstly, make sure that you have a closed particle filter and an intake filter for your concentrator that the closed particle filter is cleaned weekly with soap and water as to prevent problems that may arise due to a dusty and dirty filter. The compressor can be easily cleaned by blowing it using a pressurized air, which can come from another compressor. This will blow away the dust from the surface of the air compressor. Sometimes this alone is not enough to get rid of the dust particles from the surface of the compressor. So I would advise to use a damp cloth to get rid of the dust instead of alcohol-based solution, as alcohol reacts with zeolite and can therefore reduce the performance of the concentrator over time. Thank you, Maui.
Thank you very much, Chimwemwe, for that explanation. If we have some comments from the audience, as usual, you are always free to come off mute and add on to the explanation, or if you have some questions, you're also free to ask. So moving on with our questions, our next question says, I am working on a Sylvie oxygen concentrator. When I turn it on, only the compressor powers on, whilst the other parts of the concentrator do not. So these include the fan, the LEDs. What can be the problem and how can I rectify this problem? So I will ask Linda to take this one up.
Thank you, Maui. So for an electrical component to power on, it means it is able to receive power. And in your scenario, it shows that the concentrator is able to receive power since the compressor is running perfectly. When you open the inside of the sealed concentrator, you will notice that the compressor is powered separately from the other parts you have highlighted that they are not working. And inside the concentrator, there is a block connector where the power from the mains is distributed. And some power goes to the control board through the step-down transformer, whilst the other power goes to the compressor. So using a multimeter, check the point where the transformer is starting its power from to see if it is receiving voltage, which should be in the ranges of 240 to 220 volts. If it is receiving normal AC voltage, go ahead and check the output power of the transformer. The transformer in the sealed concentrator steps down the AC voltage from 240 volts to 15 volts. And please remember that even though it is 15 volts, it is still AC. In oxygen concentrators, some transformers have 2 output wires, whilst others have 3. So for the transformers with 3 wires, you have to measure the voltage between the 2 wires with the same color. And if the voltage is 15 volts, then the transformer is not faulty. If not, the transformer might be the cause of the problem. That is, it is not able to power the control board. That is why the other components receiving their power from the board are not working. And please remove and replace the transformer with a working transformer, and it should be of the same rating, such that it should be able to set down the voltage to 15 volts. And otherwise, if you put a setting down transformer with an output voltage which is much lower than 15 volts, other components might not be able to work well, since they will not be receiving enough power. And if it is more than 15 volts, the components might be destroyed due to high voltages. So as you can see in the graphics, there is a block connector which is used in the self concentrator. Thank you, Mary.
Thank you very much, Linda, for that explanation. I hope that was clear for everyone else. And if we have some further questions or comments, we are free to ask. So reaching this far, we will now move on to our second segment of our call, which is where we jump onto a topic of interest. And today we'll be talking about sieve bed refilling versus sieve bed replacement. So Effa is going to take us through that explanation. So over to you, Effa.
Thank you, Mary. And as you have already heard, our today's topic of interest is on replacing sieve beds versus refilling zeolite. As we all know, an oxygen concentrator unit uses 2 sieve beds, each containing molecular sieve called zeolite. The unique property of this molecular sieve is that it enables it to physically trap nitrogen molecules when air passes through it at high pressure, resulting in production of highly concentrated oxygen. While one sieve bed produces high concentration oxygen, the other pages off the nitrogen it collected while it was in the feeding phase. The paging process includes depressurizing the bed by opening the waste valve, which allows the nitrogen to exit via an exhaust muffler. During the page cycle, some highly concentrated oxygen is channeled from the pressurizing sieve bed to the depressurizing sieve bed, which backflashes out all the residual nitrogen that might have remained behind. Even though the zeolite is completely regenerative and lasts indefinitely under normal conditions, sometimes it gets contaminated faster. Some of the ways in which zeolite can be contaminated is through a leak in the system, cycle failure, as well as sieve migration. But before I go into that, let us first of all understand what contamination of zeolite is. One of the zeolite contaminants is water. The zeolite used in oxygen concentrators has high affinity to water. And when water molecules bind to the zeolite, it closes up the sieve holes that trap the nitrogen molecules. And when this happens, the nitrogen molecules do not get sieved out, which in turn reduces the purity of the air being produced at the patient outlet. And unfortunately, contaminated zeolite cannot be regenerated within the concentrator. So as I already said out, some of the ways in which zeolite can be contaminated is a leak in the system, cycle failure, and sieve migration. First of all, let us talk about the a leak in the system. How does it lead to the contamination of the zeolite? When the concentrator is in operation, a leak allows pressurized air or oxygen to escape, which results in a reduction of purity. When the concentrator is not in operation, the leak provides the water molecules in the loom to access the active sites of the zeolite, which results in the contamination of the zeolite. Another way in which the zeolite in the sieve beds can be contaminated is psychopharia. On psychopharia, oxygen concentrators, as we all know, are designed to operate with a certain quantity of water molecules, which are always present in the air. In a properly functioning concentrator, the water molecules directed into the sieve beds are captured within the first inches of the zeolite at the bottom of the sieve bed. Because this first inch of the zeolite is exposed to water molecules, it is rendered inactive and is unable to attach nitrogen molecules to the gas separation. All sieve beds within functioning concentrator contain both a small contaminated zone of sieve to hold and release water molecules and a large active zone of zeolite to hold and release nitrogen molecules. So the contaminated zone within the bed is the water zone or the moisture zone. The cycle of the pressurization and purging in the concentrator must remain intact for the sieve bed to last longer. So if the concentrator malfunctions and causes one sieve bed to receive more loom air for a longer period than designed, the moisture zone increases and the active sieve needed for gas separation becomes contaminated due to the additional water molecules that enter in the bed due to this malfunction. Our last way in which our zeolite can be contaminated is through sieve migration. What do I mean when I say sieve migration? Sieve migration is the movement of the zeolite within the sieve bed. All the sieve beds have a contamination zone, as I already said. So if this zone migrates, it then introduces contaminated zeolite into the active part of the sieve bed. The active sieve in turn moves into the bottom of the bed where it becomes contaminated by the water molecules entering the bed. This movement also can cause breaking of the zeolite, which may result into fine dust in the sieve beds. There are a couple of solutions to contamination of zeolite in the sieve beds, of which are we can either replace the sieve beds, refill the zeolite in the old sieve beds, and also you can rejuvenate the contaminated sieve bed. What do I mean when I say replacing the sieve beds? What you can either just choose to go buy sieve beds which have already been manufactured at different companies, so that you can just replace them in the concentrator depending on the model. The advantage of replacing sieve bed is that there is no risk of leakages on the sieve bed since it's coming from the manufacturer, and you have no purity problems since the beds purchased will have the light type of zeolite used in the particular oxygen concentrator. The other thing is that it is easier to replace the sieve beds since you just get the sieve beds from the company and you can just put them together. And the disadvantage of replacing the sieve beds is that it is costly since you're buying both the canister and the zeolite. And the other disadvantage is some of the manufacturers of the concentrator do not supply spare parts in certain regions of the world. So it may happen that you want to purchase some sieve beds, but they're not available in your country. Another disadvantage is that some of the models of the concentrators have been discontinued but are still in use in some countries. So it is not possible to get replacement of the sieve beds from the manufacturer. Another solution, as I already said it, in contamination of this sieve beds is that you can just refill the zeolite in your old existing sieve bed canisters. What I'm trying to say here is that you just buy your new zeolite and refill the zeolite in already existing sieve beds at your place. The advantage of this is that it is a cheaper way of maintaining concentrator with contaminated zeolite. But before replacing the zeolite, just make sure that you know the light type of the zeolite into the model of the concentrator, as using the long type of the zeolite might significantly affect the performance of the concentrator. The advantages of refilling sieve beds on your own is that no need to buy new sieve bed canisters, as you can just reuse the old sieve bed canisters. It is cheaper when it comes to purchasing zeolite in bulk, and also it is easier to access zeolite as there is a lot of suppliers of zeolite. You just have to pick any supplier you want. When you are refilling the zeolite, you might face a couple of challenges, which include leakages. Since we are using already existing sieve bed canisters we have, you may face some leakages due to difficulties to have a complete seal, since you use your own tops when you are trying to refill the zeolite in your already existing sieve beds. The other problem which is faced, it's like we are reusing the old O-rings that cannot be as effective as using new O-rings. Another disadvantage of refilling zeolite is that it is difficult to determine what type of zeolite was originally filled in the sieve bed, and if the long type of zeolite is used, it becomes difficult to get high oxygen purities in some oxygen concentrators. For example, airstep in test 10 does not perform at high purities when filled with sodium base, since the original zeolite used in airstep in test 10 is lithium. The last disadvantage of filling zeolite on your own is that there is a risk of contaminating the zeolite in the refilling process, since you have to be really mindful of the humidity in the air, so you may end up destroying your zeolite. As I already explained, another solution to contaminated zeolite is rejuvenation of the old zeolite. As I already said in the area explanation, one of the contaminants of zeolite is water. So in the rejuvenation process, it's like you remove the water from the contaminated zeolite. The advantage of rejuvenating the zeolite is that it's cost effective. You do not need to buy new sieve beds, no new zeolite. But this approach also has some disadvantages, which includes in the process of rejuvenation, there is a risk of damaging the structure of the zeolite if the rejuvenation process was not done perfectly. The other disadvantage is that it is not completely scientifically proven. And to finish up, I will talk about some of the cost-benefit analysis of some of the solutions I have explained. In refilling zeolite, purchasing zeolite is much cheaper compared to buying an already refilled sieve bed. For example, a kg of sodium zeolite, you just pay $8, and you can also purchase a lithium-based zeolite at $52 a kg. The other cost benefit is that if you are refilling a concentrator that takes in 2 kgs of lithium zeolite, this would mean it will only cost you $104 to replace the zeolite. So if, let's say, you have 10 oxygen concentrators, for example, then you would spend only $1,040 to refuel the contaminated zeolite. The cost benefit of replacing seabed is compared to refilling seabed is that replacing the whole seabed is a bit expensive if you are doing it in a bag amount. Let's say, as I already said, in refilling zeolite, you just spend, let's say, $140 for 10 oxygen concentrators. But when you want to purchase the lithium-based sieve beds, it costs you $350 for the 2 sieve beds, which will mean 350,000, 3,050, 3,500, 3,500 for the same amount of oxygen concentrators if you are to replace them by buying the sieve beds. Thank you, Maui.
Thank you very much, Efa, for that explanation. I hope that was clear. If we have some comments or questions for Efa on the things he has just discussed with us, we are free to ask. We can come off mute and then ask the questions. If we do not have any questions on that topic, we'll now jump back to our questions. And continuing with our question, our next question says, I have an oxygen concentrator that I am working on, and the compressor keeps shutting down periodically. What may be the problem with this concentrator? So I will ask Paulina to take this one up.
Thank you, Mavi. A compressor in an oxygen concentrator takes in air from the surrounding and compresses it through sieve beds to produce oxygen. Every oxygen concentrator has a start-run capacitor that starts and keeps the motor inside the compressor spinning. There are a number of cases that can lead to the malfunctioning of the compressor, as you have stated. One of the cases is a faulty capacitor. If the capacitor used is faulty, it will not be able to start and keep the compressor running. To check if the capacitor is in good condition, use a multimeter to measure the capacitance of the capacitor. Refer to the capacitance label on the capacitor. A good capacitor has to be within the tolerance of the capacitance. In case you do not have the multimeter which can test capacitance, you can replace the old capacitor with a new one or from one that's coming from another concentrator, but with the same rating. If your start-run capacitor is in good condition, then another possible cause of the jamming of the compressor is high pressure buildup in the concentrator. This mostly happens when the relief valve of the compressor is faulty. That is, it is not able to open up even after reaching the pressure set point to trigger its popping pressure. This leads to a very high pressure buildup in the system that the piston of the compressor is unable to compress the air. If that is the same with your scenario, I would advise you to use a screwdriver to pull out the top disc of the relief valve, since sometimes it gets stuck. Another cause could be as a result of a faulty temperature switch. Compressors are fitted with a temperature switch to regulate their operating temperature range. So if this switch is faulty, it can cause the problem that you have now. And in some situations, faulty compressor windings can cause the problem you are experiencing. So you would, so to know exactly what is causing the problem that you're having now, you would need to check all of these parts that I've mentioned and fix the problem. And yeah, thank you, Mabi.
Thank you very much, Paulina, for that explanation. I hope that was clear for everyone else. So moving on to our next question. So our next question says, I am a biomedical engineer. I found an air-safe 8-liter with a burnt circuit board. I replaced the burnt board with the new one. After some weeks, the concentrator was brought back to the maintenance for another assessment and repair. After assessment, I found out that the newly installed board was burnt too. What can be the cause of this problem and how can I fix this? So I will ask Kowinda to answer this one.
Thanks, Morgan. So, very common problem for all the models of oxygen concentrators. So nowadays, in the summer season, it is very common. So the cause of such burns is power fluctuation or surging. So when the machines or oxygen concentrators are run without voltage stabilizers with the unstable power supply, the circuit boards are prone to such damages. So voltage stabilizer is an electrical appliance which is designed to deliver a constant voltage to a load at its output terminals regardless of the changes in the input or the incoming voltage supply. So replacing with a new circuit board can be much costlier. The affected parts in the as is seen in the picture, the red color capacitor, that is a paper capacitor normally used, and the other is number 2, that is the fuse, which are the main parts that are blown due to power surges. So the affected part in the picture are the varistor and fuse and are replaceable. So they can easily be replaced by soldering. So these components are easily available in the market as paper capacitors or varistor. To avoid such occurrences or problems, so it is best to use voltage stabilizer with every oxygen concentrators. So it can really reduce the failure rate nearly by 50%, as we have seen. Today only in India, we have replaced 2 PCBs today only due to these surges. So that is a main cause. So it is always suggested to use the voltage stabilizers to overcome these problems. Thank you, Mavi.
Thank you very much, Kowinda, for that explanation. I hope that was clear enough. But in case we have some questions, we are free to ask. So we also have a poll at the end of this question. So Amaprit, please launch the poll.
I will do. Our next poll question is, have you ever replaced the identified circuit board components? I am confident that we've all seen problems with power fluctuations and variations, especially nowadays with the cost of fuel increasing and the demands for fuel and electricity increasing as well. So I'm sure this is something that we are all familiar with. And if we look at the responses, it is a lot of yeses and just a few nos. And I would imagine the no's are where you replace the entire board as opposed to just the circuit board itself. Thank you, Maui.
Thank you very much, Amaprit. So we'll now take one final question and then we'll wrap up our session for today. So the question says, I am a biomedical engineer at a certain hospital. I was working on a respironic oxygen concentrator. After I repaired the machine, I put it to the test to see how it performs, and unfortunately, it turned itself off. The unit felt like it was overheating, and when I measured the temperature, it was 39.5 degrees Celsius. What could be the cause of this? So I'll ask Mteto to take this one up.
All right, thank you, Maui. So high temperatures on oxygen concentrators are not good for oxygen production. So for this reason, it is advisable not to put oxygen concentrators close to the wall, as it blocks the ventilation holes, making the air circulation process difficult, resulting in high temperatures. So you must also make sure that the cooling system is working fine. So when you talk of the cooling system, it literally comes from mostly the fan inside that cools the compressor. So another thing you need to check is the orientation of that fan. So position it so that it's providing some cooling to the compressor. So if the fan is facing another direction, the cooling process will not happen, making the concentrator become hot and switches itself off. So it is recommended that the operating temperature should be within like 13 to 32 degrees Celsius. And please make sure that the atmospheric temperature of the loom is maintained as per manufacturer's instructions. There should also be adequate ventilation to let out the heat that is produced by the compressor. If there is less ventilation, the temperature surpasses the normal range, causing the oxygen concentrator to turn itself off. So I remember earlier, actually, Sharon explained the problem they are facing where they are fixing oxygen concentrators right now, that it was overheating. And after like pushing the concentrators away from the wall, and these concentrators are performing fine. So I think this is similar to what Sharon was explaining. Thank you, Maui.
Thank you very much, Tato, for that explanation. So reaching this far, this now brings us to the end of our concentrator talk today. But before we all jump off, we have an announcement. So Amaprit, please make that announcement.
Thank you very much, Maui. So as I think we all missed quite sadly at the end of May, we did not have a concentrator talk, an oxygen talk. So our oxygen talk is where we bring experts, not the technicians that you know and love that are on these calls every week, but instead experts from another part of the oxygen-related infrastructure. So we've in the past had Peak Scientific come on and talk about troubleshooting with PSA plants. And our most recent one was with Miss Debbie Aloyo talking about the importance of maintenance and repair schedules in hospitals and how she works with her biomedical engineers. And I am very, very excited to announce that our next oxygen talk will be on June 23rd, and we will have Miss Martha Gatley from the Clinton Health Access Initiative come and join us. Martha, along with, I think, one of her colleagues, will be talking about cylinders, cylinder manifolds, safety around cylinders, and every other question you could have within 45 minutes about oxygen cylinders as a method of delivery. So we will, of course, put this in all of our recap emails, but we are very, very excited for you to join us to hear Miss Martha Gatley speak in just a couple weeks during our usual time, but for our oxygen talk series. Thank you, Maui.
Thank you very much, Amaprit, for that announcement. So just a reminder to all of us that please share with us your email address if you haven't already done that. Also, don't forget to visit our website and our YouTube channel so that you get updates and read about the work that the Oxygen Alliance is working on. So reaching this far, I would like to thank everyone for joining us for the call today, and I would like to wish you a great week, and we'll see you again in our next Concentrator talk. Goodbye.